So today we have a meeting about deploying Iroha. The reason, the initial reason for this meeting is that we updated the scripts for deploying Iroha, and today DevOps team lead of Soramitsu, Artyom, will be presenting how to deploy Iroha now and also answer the questions. So that's antitrust policy notice. We do that for every Hyperledger meeting, so you can take a look at it. The agenda today: ways to deploy Iroha, then changes in deployment process that came with release candidate 3, and where to find the instructions, the relevant readmes and documentation. Then we'll have a little demo about how to deploy Iroha, and then questions and answers. And now I'm presenting you the speaker today, Artyom Bakhtin.
Okay, hello everyone. My name is Artyom. I'm a lead DevOps engineer at Soramitsu, and today we'll be talking about the numerous ways of deploying Iroha and what has changed since the last releases, several ones. We actually built Iroha on our continuous integration platform at Jenkins, and every push to master branch initializes a build of a binary file, and then it's packaged into a Docker container, which is available on Docker Hub. It's Hyperledger Iroha. So if you, for example, want to pull it, you can just Docker pull Hyperledger Iroha, and there are several Docker tags. There is a latest tag which corresponds to the master branch. There is also a develop tag which corresponds to the develop branch of Git repository, and there are some text that identifies the specific version. And since the latest version of Iroha is 1.0 release candidate 3, you can pull, for example, this tag, and it should pull you the latest. Oops. Yeah, this will basically download the latest Iroha version. All the available texts you can see on the Docker Hub. In order for Iroha to work, it requires a Postgres running alongside. It is configured with a config file, which is mounted into the Docker container. And yeah, today we'll be talking solely about how to deploy Iroha that is built and pushed as a Docker container. So it's not deploying a binary on the bare metal, but at least you have to have a Docker daemon installed. So there is a config file that tells Iroha where to find Postgres, which is called config docker. You configure the user, the password, the Postgres port, and the host it should connect to. There are some other parameters which are not relevant for today's talk. You can find the description of them in the Iroha docs. There is also a block store class, which the data on that should be persisted. And if you want to do that with Docker, you should either bind mount this folder as a Docker volume, or you can just mount the folder on your computer to this one. So this is to allow Iroha to survive restarts, because if you don't do that, you will lose all your blocks after the containers shut down and restart. Everything actually can be done manually, so you can just bring up a Docker container, configure the parameters in the config Docker file, and make sure that the Postgres is available from inside the container, and Iroha can connect to the Postgres. But if you want to deploy more than 2 or 3 Iroha peers, this is kind of tedious and requires a lot of manual effort. It's error prone, and in order to avoid these situations, we have the scripts available in the repository of Hyperledger Iroha. As soon as you pull the role, there should be a folder which is called deploy, and inside it the folder called Ansible. And yeah, all the scripts are written as an Ansible roles playbooks. For those who don't know what Ansible is, this is a automation tool that allows to declaratively describe what should be installed on the machine, how it should be done. Then you can run the same set of scripts on multiple hosts and hopefully get the same result. Yeah, I'm asked to show how can you find the config Docker file. And it's in repository, you can find it in example. Config Docker. This is the default one. And inside the container, we don't store this one. So right after the container is built, there is only Iroha binary, but no any config files, and you have to pass all the configurations from your host machine. It can be done either by Docker volume or just by mounting the directory from the host machine. What should be inside the Docker container, and what are the requirements for running an Iroha? At least you should have a config Docker file, which is the syntax is I already showed you. There should be 2 keys, which actually the one key pair, the private and public keys. These are required for communicating with other Iroha peers. These are not 0 and not 0 private and not 0 pub files. And you also need the Genesis block file. Genesis block is the very first block of the block store, which describes what peer the network consists of, what users are initially added to it, what permissions do they have, what roles do they have, what assets do we create the initial Iroha startup and things like that. So all these files are available in example folder. You can find them in Hyperledger Iroha Git repository, GitHub repository. And if you have any questions regarding what files should be in the Iroha container during the run, you can find it in Iroha documentation in Iroha read docs. Okay. Now we have, as I said, the set of Ansible scripts that deploys Iroha on remote hosts. You can find them in deploy Ansible folder. The Ansible consists of basically three things. The roles. Roles describe the actual steps that require to configure and run Iroha. And there are also playbooks which describes which roles should be run on the host. And today we'll be running two roles in a single playbook. One is Docker and another one is Iroha itself. And there is also an inventory which basically says where should we configure these roles. Okay. The Iroha Docker role is located in roles Iroha Docker. It consists of several steps. There are several major ones. Which is a configuration of Iroha with helper scripts and then the deployment. So there are actually two major ways of deploying Iroha on the remote hosts. The first one is deploying Iroha in such a way that the Iroha peers can communicate with each other over the internet, or if you are deploying peers in the local network, they will be communicating with each other over the LAN. And another major deployment use case is when Iroha peers are communicating with each other over Docker overlay network. And the difference between those two is that in the first case scenario, when you deploy the first case is that Iroha peers are communicating over the internet, and in the second one, when they communicate over the Docker overlay network, they communicate usually over the encrypted channel. And this is beneficial if you want to secure your Iroha communication. Today I will show you both of these scenarios, and we will start with the basic one, when the Iroha peers are communicating over the internet using public IP addresses. Okay. There are several configuration parameters that can be tuned if you want to. They are in the defaults folder, and they are described pretty good. So yeah, there are a major parameter that says whether we want to configure the overlay network or not, And if we do not do this, then Iroha peers will be communicating over the internet or over the local network if you have this communication allowed. There is also a container name, which is basically how the Iroha containers will be named on the host. What's interesting here as well, the Iroha network name, this is how the Iroha network will be called. Yeah, and there is also Iroha Docker tag and Postgres Docker tag. These are the Docker tags which says which versions of either Iroha or Postgres will be deployed on the remote host. There are two parameters responsible for the base port of the Iroha container, and the reason is we have two different ports is that Iroha peer port is the variable that is responsible for configuring the port which is used for Iroha peer communication, and there is also a Tori port which is the port for end user interactions. And there are also parameters that are put into config docker file, which I previously showed you. Okay. There is also a README file which pretty much describes all what I just said in a good amount of details. And instead of going through this README, since I already have some configuration files prepared, I will just show you. Yeah, okay. I prepared four virtual machines, and two of them will be used for the first deployment scenario when peers are communicating over the internet, and two other ones will be used for deploying other part, which is Docker overlay network. And you can actually, you must to define some parameters. Yeah, and these parameters are defined in playbooks. So there are some parameters that are required to be tuned before you can proceed with the deployment, and those parameters are defined in the playbooks Iroha Docker. And since we are starting with the first scenario, are in Iroha demo. Yeah. And what it basically says is that we want to deploy our Iroha on every host that will be defined in some file. I will show you later. The strategy linear is required to allow to configure some local things, and it doesn't behave well with non-linear strategy. And there are roles that should be rolled out during the deployment, and you can see there is a Docker and the Iroha Docker roles, and the Docker one is required to deploy the Docker itself, so you can use just a bare metal machine with Python 3 installed, and you should be good to go. Everything will be installed for you. And there are some variables, which is the host names. Host names, we don't use this variable in this scenario. And the other ones are Iroha Docker tag. So Iroha version which will be deployed overlay network is false, which means the Iroha peers will be communicating over the internet and Iroha network name, which is Iroha demo. And there is also a file which says where should we deploy all of this. And we'll be using two hosts to deploy several Iroha nodes on them. And since we don't want to just deploy one Iroha node on each host, this parameter is also tunable. We can say that we want to where is it? So there are also some parameters that are overridden on a playbook level. And for example, 63 says that we want to deploy 4 replicas of Iroha on each host, on that host. And since we have the another one, this one says that we want to deploy 3 Iroha replicas on that host. So in total, we will be having 7 Iroha nodes deploying onto physical machines, running and communicating with each other over the internet. So let's proceed with the deployment. And here is the command, and what it says is that I want to SSH on the host using user Ubuntu, and then I want to sudo, and then I want to use this inventory file, which in fact this one, and this is my SSH key file, and this is the playbook that I want to run on those hosts. And I think this is it. Just hit enter. And what it does is, first of all, installs Docker. And since we already have Docker installed on that host, it just confirms that everything is installed by saying OK. And then we generate configs, move those configs and keys to the remote host. Seems that everything is good, and we should have 2 of our hosts are bootstrapped with Iroha. And let's confirm that everything is running. So we have 3 Iroha here, along with 3 Iroha with 3 Postgres instances. 1 Postgres instance for Iroha. And let's confirm that they can communicate with each other. And yep, since we see empty here, and since we have enough volts in storage, this basically means that the consensus is working, which basically means that they can communicate with each other. Okay, since we already deployed the first version of the first option, I would say, we can go through the actual steps that are defined in the Ansible role. I need to switch the sharing option. What I want to show you is some internals of the Ansible playbook. Of course, you can find them in the repository, in the Iroha repository. There is a role which is called Iroha Docker, which consists of 4 folders, and there is a defaults file, which I already showed you, which describes the default parameters, and if you don't tune them during the deployment, these ones will be used. And there is also a files folder. This is basically where all the magic happens. There is a config.gen bash script. What it does is generates keys and fills in IP addresses or host names into the Genesis block. This script can be used as a standalone version if you don't want. I mean, if you have some other scenarios than which are defined in this Ansible role, you can use the script as a helper to generate as many keys as you want, and for example, manually just move them onto remote machines. There is also a Python script that generates SHA-3 ED25519 compatible keys, and it should be replaced, I think, because we have a library, the pure Python library, which behaves similar to this file, but can also generate private and public keys. And there is another Genesis peers Python file which fills in the values for Genesis block. And by values I mean the hosts that describes the Iroha peers. And there is a Genesis block itself. And if you want to add something to this Genesis block, or if you want to add some users, if you want to add roles or some comments or assets, it should be done here because the Genesis block is taken from this folder and then distributed onto each Iroha peer. And there is also a patch that allows you to work with previous Iroha keys format, which in the previous ones are the versions below RC1, I suppose. You can just apply this patch and you should be good to deploy some older versions of Iroha if you have this need. There is also a templates file folder with some templates, and there is a Docker compose template that values are filled, and this file is then transferred onto the remote host. There is also a tasks which actually says what to do and describes the steps that are required to configure the Iroha, generate secret keys, and then distribute them over to the remote host. Okay, we have the second scenario left, which is the deploying the remote hosts that are connected using the Docker overlay network. Just a minute. The second scenario is more complex one because it requires you to first set up the overlay network, and the overlay network is behaves itself as a LAN network, but you can have hosts geographically distributed over the internet. So, for example, you have one node somewhere in US, and then the other one somewhere in the UK, and you want to Iroha peers deployed on these hosts to communicate with each other, but you don't want to communicate them over the internet. Instead, you want to present the network as a LAN network. It also allows Docker containers, which will be in this Docker overlay network, to communicate using the host names as if they were running on the single machine. Instead of doing some complex setup of overlay network, and complex setups includes, for example, Docker plugin like Calico. I will be using some basic setup, which includes the deploying etcd, which is a key value storage that allows to keep the IP addresses of the nodes in the distributed key value storage, and then Docker daemon can then use this key value storage to fetch and update nodes of IP addresses of the nodes. And for that we need etcd, which is here. And we want to first stop the default Docker, use default parameters, because we need to override them. Then we need to deploy etcd cluster, which consists of 2 nodes. And here we go. And then we want to confirm that our etcd cluster is doing well. Yep, cluster is healthy, and it consists of 2 members. Both of them are healthy. Here we can see the addresses of the private addresses, local area network addresses. You can as well use some public IP addresses just to make sure that these machines can communicate with each other on these ports. And then we need to run Docker itself with some custom configuration, which basically says that we want to use this etcd key value, distributed key value storage. Okay, we have a Docker running on these two hosts, and just to confirm that both of these Docker daemons are using the same key value storage, we can create some network. And we can verify that the same network is appeared on the other host. Yep. And we can as well remove this network. And it should be absent here as well. Yes. Okay, there is another playbook which demonstrates how should the deployment be done for cases with overlay networks, which is described in this playbook, and it's pretty much the same as the previous one, but here is the option, default option over being overridden, and sets the overlay network to true. And we're using the same command, but with a different inventory, which are using two other hosts in the same key file and different playbooks, as you can see on the top. And enter. Overlay network, for example, are used in the Docker swarms, but our playbook does not work with Docker swarms. There is actually a Kubernetes specification file, but I will not be talking today about it. It's in the same folder as Iroha Docker role, but it is called Iroha Kubernetes, suppose. Seems that everything is okay. Yep. The machine was configured with overlay network and 7 Iroha peers, 3 on the first machine and 4 on the second one, and everything seems to be working because the consensus is working, which means the Iroha nodes can communicate with each other with no problems. Okay, these are the two major use cases that I wanted to share with you today, and I think this is it. In order for HostWars files to work, you need to first name them after the host names that you used in the inventory file. So as you can see, the file named exactly as it is defined in the inventory file. So we do have here two hosts with two public IP addresses, and if you want to override some of the default values that are defined in a role, you need to create the file with the same name, and you can just put any, you can put the value for the variable that you want to override. This is how it's created.